As any gardener or farmer can tell you, nitrogen and phosphorus are chemical elements found in soils and fertilizers that plants need to grow. They also know different ratios of nitrogen and phosphorus are ideal or detrimental for different types of plants and crops. Nitrogen and phosphorus also play a powerful role in lakes and can alter the clear and pristine waters of low-nutrient lakes. Now a team of researchers led by scientists from the University of Montana's Flathead Lake Biological Station has examined nearly 40 years of nutrient dynamics in Flathead Lake. Their work was published July 11 by the Proceedings of the National Academy of Sciences. Since the early 1990s, I've worked to better understand when and where nitrogen and phosphorus limit the growth of lake organisms, such as plankton, said FLBS Director Jim Elser, a member of the National Academy of Sciences and the lead author on the study. It turns out that strong imbalances in the ratio between nitrogen and phosphorus in ecosystems and organisms can have big impacts. I wanted to see if this was going on in Flathead Lake. For over a century, research and monitoring programs at FLBS have served as the first line of defense against ever-looming threats to the renowned water quality of the Flathead watershed. Flathead Lake is known for its clean and clear water, largely because the geology encompassing its watershed is ancient and low in nutrients, especially the nutrient phosphorus. This means there are very low levels of nutrients that can be weathered from the bedrock to reach the lake through rainstorms and snowmelt. Therefore, naturally there are low levels of nutrients available for lake algae to grow, and Flathead Lake remains clear and blue instead of green and murky. This low background of naturally supplied nutrients makes Flathead Lake very sensitive to human-driven inputs of nutrients. Such human-driven inputs of nutrients into Flathead Lake and associated algal blooms raised concerns in the 1970s and 80s. Subsequently, research conducted by FLBS scientists led to nutrient reduction measures in the Flathead watershed, including one of the nation's largest bans on phosphorus-containing laundry detergents and a multi-million-dollar overhaul of local wastewater treatment facilities to remove phosphorus too. But in recent years, Elser and his colleagues began to wonder if monitoring nitrogen and phosphorus in isolation was enough. Given his long history in developing and testing the theory of ecological stoichiometry, the study of the balance of multiple chemical elements in ecological interactions, Elser was eager to find out. We found that the overall levels of nitrogen and phosphorus in Flathead Lake and its surrounding rivers and streams, while variable within years and year to year, are low but not increasing, said Elser. In fact, nitrogen and phosphorus levels coming into Flathead Lake from its larger rivers actually appear to be slowly declining. This is great news for the water quality and clarity in our beloved Flathead Lake. While water quality in many of the world's lakes is declining due to increasing nutrient inputs. Then came a surprising development. While the overall levels of nitrogen and phosphorus in Flathead Lake weren't increasing, the researchers discovered that the lake has sustained a high ratio of nitrogen to phosphorus across a span of 4 decades, often reaching values that greatly exceed the normal nitrogen to phosphorus recipe. When the ratio between nitrogen and phosphorus is high, as it is in Flathead Lake, plankton growth is likely limited by lack of available phosphorus for much of the year. Through a series of experiments, the team of researchers showed that Flathead Lake phytoplankton are phosphorus limited. This means the algae are forced to build cells that have low content of phosphorus, making them not particularly nutritious. For the tiny lake animals, zooplankton, which eat those phytoplankton and thereby sustain the lake's high transparency, this amounts to the equivalent of a junk food diet. As a result, the zooplankton also become phosphorus limited and their abundance is low. Finally, the team showed that the strong nitrogen to phosphorus imbalance in Flathead Lake sets the stage for potential production of the greenhouse gas methane. This occurs when phosphorus-hungry microbes start to scavenge phosphorus from organic molecules and produce methane as a byproduct. These findings have implications not only for Flathead Lake but also for lakes globally. Wastewater treatment systems, agricultural runoff and urban influences are increasingly recognized as contributing to nitrogen to phosphorus imbalance in a variety of situations. At Flathead Lake, implementation of wastewater treatment processes that more effectively remove nitrogen would help balance the lake's nitrogen to phosphorus ratio, Elser said. James J. Elser, Sean P. Devlin, Jinlei Yu, Adam Bowman, Matthew J. Church, John E. Dorr, Robert O. Hall, Melody Haller, Tyler Johnson, Trista Vick Majors, Cassidy White. Nutrient imbalance in Flathead Lake. Science Daily, 12 July 2022. ift.tt/uopt04b. The University of Montana. 2022, July 12. Nutrient imbalance in Flathead Lake. Science Daily. Retrieved July 12, 2022 from ift.tt/uopt04b. The University of Montana. Nutrient imbalance in Flathead Lake. Science Daily. https://ift.tt/uobt04b. Access July 12, 2022. Thanks for watching. Please subscribe my channel for more videos.